Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dogba Jr., your math tutor. And in my today's lesson, I'll be looking at system of linear equations, a continuation of our previous lesson. So under this lesson, we will be discussing particularly determining the number of solutions. So when you are given a system of linear equations, most times you have either one solution, or you have infinitely many solutions, or you have no solutions. There are also cases wherein you have to determine whether the system of linear equation is consistent or is inconsistent, or they are dependent or independent. So we want to look at all of these cases, and we will be looking at them under the graphing method. So we want to determine as to whether a system has one solution, many solutions, or no solutions by method of graphing, not by manually solving the problem, but just to graph. So in summary for the graphs, there are three major graphs: one solution graph, infinitely many solutions, and no solution. So here are the graphs. One, when you have one solution, it means the graph, the solution will intersect, they will have an intersection at one point. When you have no solutions, it means the graph of the equations will be parallel to each other. And when you have infinitely many solutions, the graphs will coincide. Now, this is what I meant. You have, if you have a system of equations, so probably the first equation might be like this, the graph of the first equation might be like this, and the second one will intersect the previous graph. So this is one solution. So if you have a case wherein you have a graph and the solution is like this, the two solutions are, the two equations are parallel to each other without intersection, it means it has no solution. And when you have a case wherein the graph coincide, the first graph is like this, and the second graph runs in this first graph. So when it coincides, it means it has many solutions, because all along you will have many solutions because they are intersecting each other at all of the points on the both lines. But for this, they intersect at a single point, so it has one solution just at this point. So for this one, you have this solution, many solutions on this line. That's why we call it infinitely many solutions. This one, no solution because it do not intersect. So let's see how we can solve these problems. So the first problem says we must determine the number of solutions as one, infinitely many solutions, and no solution. Or no solution by graphing, and also classify the system as consistent, inconsistent, dependent, or independent. So when it is consistent, it must be either dependent or independent. When it is inconsistent, it must also be independent or dependent. So we'll look at those cases in each of these problems. So the first problem says x minus y equals to minus 2, x minus y equals to minus 2. So we see that the two equations are the same, right? So it means the first graph of this equation will be the same graph of this one. But let's see how it looks like. So now we have our the first method I told you, the first thing we must find the y-intercept. So we want to solve for this equation in a sense that it will be in the form y equals to mx plus b. So want to make the equation to be in this form so that we can just identify our slope and our y-intercept. So what is our slope? Our slope is m. So let's take one of the equations. You have x minus y equals to minus 2. So we send this x across the equal sign. We have minus y equals minus x minus 2. Right? So if we divide all sides by minus 1 to get rid of this negative, minus 1, minus 1. So it means y will be equals, because negative divided by negative is positive. Negative divided by negative is positive as well. And then this is also positive. So we will have y equals to mx. So our m is 1 and our b is 2. So the y-intercept now would just be 0, x is 0, y is 2. And then the slope is just equal to what? 1. So we want to graph. When x is 0, y is 2. So there is 0, y is 2. So we check 1 unit, 2 units. So we shade this area. And then the next one, the slope. The slope is 1. So you have like 1 over 1. So we move from here, we move 1 unit in the y direction, 1. And we also move 1 unit in the x direction. So we move 1 unit here in the x direction, 1. So we can just shade this place like this. So this will be our first graph, the first one. So since the equations are the same, the next graph will just run through this initial graph. So because the two graphs coincide with each other, they are running through each other. So we will have infinitely many solutions. So we will have infinitely many solutions for this problem. Many solutions we're going to have. Now, what's about the classification of the system of equation here? Is it consistent? Yes. The system is consistent because it has many solutions. The only time it becomes inconsistent when it has no solution. Now, also, is it independent or dependent? So you see that the both equations graphs are within each other. They are coinciding with each other, right? So it means they are depending on each other. So this is dependent. So we call this consistent dependent system. So this is consistent and it is also dependent, right? Because one graph is depending on the other. It's dependent. Okay. So if we were to just solve this thing, x minus y equals to minus 2, x minus y equals to minus 2. If we were to solve it using elimination method, for example, we put a negative right here so that we change one of the signs. So you will have x, we rewrite the first equation, x minus y equals to minus 2. The second one, minus x, negative times negative is positive y, negative times negative is positive 2. So you see that x cancel x, y cancel y, so this whole thing is 0. Minus 2 plus 2 also 0. So whenever we solve a system of equation and then we end into 0 equals to 0, or 2 equals to 2, or x equals to x, or 5 equals to 5, as long as the both sides of the equations are the same values, it means you have infinitely many solutions and you have a consistent dependent